In this class, let us learn mutual induction. Consider two coils. The first coil is connected to a load and a galvanometer. The second coil is connected to an AC source. Since it is an AC source, the current through the coil varies continuously. A varying current induces an EMF in the neighboring coil. This phenomenon is known as mutual induction. The flux associated with the first coil is directly proportional to the current flowing through the second coil. Therefore, we can write phi1 proportional to I2. Or phi1 is equal to M12 into I2, where M12 is a constant known as mutual inductance. Mutual inductance of coil 1 with respect to coil 2. It is equal to phi1 by I2. So we can define the constant as the magnetic flux linked with the primary coil when unit current flows through the secondary coil. The first coil is called primary and the second coil is called secondary. The varying current in the secondary coil produces EMF in the primary coil. The induced EMF in the primary coil E1 is equal to minus d phi1 by dt. It is equal to minus M12 into di2 by dt, because phi1 is equal to M12 I2. So M12 is equal to minus E1 by rate of change of current through the secondary, or it is the ratio of induced EMF in the primary to the rate of change of current in the secondary. Its unit is Weber per ampere or Henry or ohm second. Now let us see the mutual inductance of two long coaxial solenoids. Let us consider two coaxial solenoids of same length. The inner coil is of radius R1, number of turns N1 and length L. The outer coil is of radius R2, number of turns N2 and of same length L, where R2 greater than R1. Let a current I2 flows through the outer coil. The total flux associated with the inner coil phi1 is equal to N1 phi1. But N1 is equal to small n1 into L, where small n1 is the number of turns per meter. So the total number of turns is N1 into L. Flux phi1 is B dot A. The magnetic field is due to the current flowing through the outer coil I2. So the field B2 is equal to mu0 N2 I2. And the area of the inner coil A1. Substituting for B2, phi1 is equal to mu0 N1 into A1L I2. So the mutual inductance M12 is equal to phi1 by I2. It is equal to mu0 N1 into A1L, where A1 is pi R1 square, area of the inner coil. Similarly, mutual inductance of outer coil with respect to the inner coil M21 is equal to phi2 by I1. Phi2 is the flux associated with the outer coil. It is equal to N2 B1 A1. Here the field is produced by the current I1. So B1 is equal to mu 0 N1 I1. But the field B1 exists inside the solenoid, inside the inner coil only. So the area A1 is taken. So M21 is mu 0 N1 into A1L. So from these two equations, it is clear that M12 is equal to M21. Thank you.